All right, hello everybody. Thanks for joining the first episode of the binding status. This is just going to be kind of an introductory episode to Crossplane, and other episodes in the future might look somewhat different. But I will start off by introducing myself. So my name is Daniel Mangum. I am a software engineer at Upbound, and I work on Crossplane full time. And I'm excited to be doing this show, and we'll kind of evolve it as we go along, just to meet the needs of the community and understand any questions that people have, and try to do deep dives into things that are really meaningful for different people. So as you join, please feel free to jump in the chat here on the YouTube video. If you have any trouble with sound, or you just have any questions about what we're doing, please feel free to offer them there, and I'll stop periodically to look at the chat. I also have the Crossplane Slack open, so you're welcome to jump in there and offer any thoughts or questions. Besides that, I'm just gonna go through kind of a script that I've planned for today. But if there's a need to kind of diverge into other areas, then we'll make sure to do so. So thanks again for joining, and let's get started. So let me move over to streaming here. So also in the bottom corner here, here's my Twitter handle, #Dan. So that's if you want to reach out to me directly with any questions or feedback following this. That's also my name on GitHub and virtually everything else. So please feel free to reach out at any time about Crossplane or anything else. So to get started here, let me pull up the Crossplane website. So I know that probably some people on this stream are familiar with Crossplane, familiar with Kubernetes. Others might be familiar with Kubernetes but not Crossplane. And so we're going to kind of try and do a very inclusive overview of what Crossplane is, covering some of the Kubernetes concepts as well. So once again, if you have any questions about any part of that, then please feel free to ask them. So Crossplane is, its stated mission is to serve as the open source multi-cloud control plane. So if you've ever used a cloud provider like some of the ones we list here, we have GCP, AWS, Azure, some of the bigger ones, although any managed service provider will be able to offer provisioning resources on Crossplane. But essentially what it does is it takes these different APIs you use. So whether using the console, like the AWS console or Azure GCP, or you're using their API directly, you have to learn their conventions, right? You have to learn how they do things, how you can provision a virtual machine on GCP versus AWS or something like that. And what we're doing is kind of trying to serve as a layer above all of those things, right? Somewhere where you can be agnostic about how you provision resources, and you can just say I want a virtual machine, and then have the underlying work choose the cloud provider based on how administrators in your organization have set that up. And we're doing that through not a new API, because we don't want to create just another thing for you to learn. We don't want to, if you already know the GCP API, we don't want to introduce another API, for instance, for you to have to understand. So we're standardizing on the Kubernetes API, which has gained a lot of popularity provisioning containers across compute resources. So we're using that same API and extending that as kind of a ubiquitous approach to provision managed resources on different providers. And we'll get into kind of how that works. But how this is different from sort of some other infrastructure as code tools is Kubernetes has this concept of reconciliation. So if we want to look in here, let's see if we can find API kind. So let's look at Kubernetes API kind. So there's these built-in types to the Kubernetes API. Let's see if we can find here API documentation. Let's see. Here we go. So there's built-in kinds in the Kubernetes API, and essentially what these are just objects that specify different qualities that you desire a state of a resource to be in. So for instance, a pod is the basic unit in Kubernetes, and you can specify these different things in the pod spec here to kind of determine how you want a pod to operate, right? How many replicas, that sort of thing, or that would be in a deployment, but what container to use, host alias, you can see all of these sorts of things here. And what Kubernetes does is it takes that specification that you provide and it constantly brings the status to that specification. So if a resource gets out of sync with its specification, then Kubernetes will automatically reconcile that back to its specification. So we do that same approach with managed resources. So Kubernetes also has this concept of CRDs, custom resource definitions, and you can read about all of this on the Kubernetes documentation, which is very thorough. But essentially what it does is allows you to take a kind like a pod or something like that and create your own custom resource. So in the context of Crossplane, that would look like something like a AWS EC2 instance or something of that nature, any managed service you can provision. And it allows you to provide that same specification and then have a custom controller that reconciles that specification with the status. So if you provision a bucket, as we'll see later on in this episode, and then that bucket gets deleted, it'll automatically bring that bucket back up. And that's just kind of a simple example of what that might look like. So let's see if we can dive into a little more Crossplane specific things here. So a very useful document when you're getting introduced to Crossplane, and we'll hop over to it here, is this architecture document we have, which essentially, and some of this is probably out of date at this point as the project has evolved, but it lays out the kind of motivation for the Crossplane project. And one of the things I think is really useful is this proposed architecture section here. So if we go to the architecture, let's see here. We get this idea of claims, classes, and resources, and then external resources. So essentially, Crossplane provides a separation of concern as well as providing this API that you can provision across all cloud providers. And what that means is this resource class here is a Kubernetes object. It's one of these custom resource definitions that we specified. And we'll see one of these later in a moment as I provision some resources as an example. And it basically has all of the specifications inside of it. Then we also have a claim, which is saying I want an instance of the resource provisioned in the manner that this class specifies. And these work together to create a resource which represents an external resource. So we usually refer to this as a managed resource in Crossplane. So it is a one-to-one mapping with an external resource. So you would have for instance, GCP bucket resource in Kubernetes, which is an object in Kubernetes that represents an actual GCP bucket in GCP. And that bucket will be provisioned by parameters that a class provides that is referenced by a claim. So these classes can be referenced by many claims and just basically provide details for provisioning the resource itself. So let's see, what else can we get into here? There's also the idea of policies, which are new, and this is a great picture here of kind of how that claim and class work together. Policies are something that are not in this architecture document, but they have been recently introduced as we move to a more strongly typed sort of resource class, which I'll get into in more depth later. But policies, which it may be helpful if we just look at a policy at this point, so don't want that yet. Let me pull this up here. So, and this would be a good time to mention, in this Crossplane TBS repo, which is the binding status, which is this show, you can go here, and if you go in episode 0 assets, this has all the assets that we're going to use throughout this episode, so you can actually follow along if you'd like to. And we're going to look here at some of the things we have in here. So let's go into episodes 0 assets. So in the assets folder, we have bucket, cache, and provider. So we're going to start with, we'll start with provider here. So and GCP. So essentially what a provider is it's the basic thing you need to set up to be able to create resources on a cloud provider. So what you'll see here is basically a Kubernetes secret, which is a built-in kind, as well as a provider, which is a Crossplane specific kind. So we create a custom resource definition that allows you to create instances of providers. And basically what this does is just provides connection information for different resources to reference to be able to connect to cloud providers. I'm going to check real quickly here if there's any questions. It doesn't look like it. We do have one person who introduced themselves. Looks like Eon Patapon, maybe. Sorry if I didn't pronounce that correctly, but welcome. Thank you for introducing yourself. And Marcus is here. Marcus is one of my coworkers. Thank you for being on the live stream here. So going back, so we have this provider here, and after you create the provider, you're able to provision resources on a specific provider. So this would be a GCP provider here. And if we go back out, let's look at example of a claim and a class. So we'll look in bucket GCP. So in here we have a claim and class. And if we look at the class, this is a generic resource class. And what I mean by that is it's part of the core Crossplane API. And it's just of kind resource class. So it's not a specific type or anything like that. And it just has this parameters section, which specifies parameters that we're going to use to provision a GCS bucket. And then a provisioner that allows for specifying the platform that the bucket is going to be provisioned on. And then we have a claim here that references that bucket. So GCS bucket and Crossplane system, that's just the class that we would create with that class.yaml we just looked at. So those are the basic units as I was talking about earlier, and I'll show you a policy in a moment. But I'll just go ahead and jump into what we can do with Crossplane here, because I think that will be the most useful illustration and provide the most understanding. So once again, please feel free to offer questions as we go through this portion. So let's go to provider. So the first thing we need to do before we set this up even is I have a local Minikube cluster running, single node cluster. And you can install Crossplane. Crossplane is installed as just a Docker image and a pod, just like any application could be, into the into the Kubernetes cluster. So you could use Minikube, you could use microkates, you could use a cloud provider flavor of Kubernetes, or you could just run it locally. So any Kubernetes cluster will do, and we have some helper scripts here. So I'm actually in the Crossplane repo here, and like I said, I'm on this branch that will likely be merged soon that moves to the KubeBuilder v2 pattern. So if we actually, that's an important thing to point out, which I'll do very quickly here. If we look at the Crossplane repo, and please feel free to come here and provide any contributions you wish, and we'll get into sort of our roadmap in a bit. But right now we have our package directory here, which has our APIs and our controllers, which is kind of the two most important parts of that. So the APIs are where we define our custom resource definitions for the different providers. So if you look in AWS, for instance, you'll see, let's look at cache v1 alpha 1. You'll see something like replication group types. And then if you look at, let's see, GCP, and you look at cache, you'll see cloud memory store instance types. So that's their individual flavor of types there. And then in the controller directory, this is where we specify the controllers that provide that reconciliation that I was talking about earlier that Kubernetes introduces. So in the new kind of directory structure we're moving towards, those APIs are broken out. So we have an APIs directory at the top level, which is these core Crossplane APIs. And then we have individual cloud provider APIs. So once again, this is defining these types, which eventually get compiled into the cluster here. And you can see all of our different CRDs that we install into the Kubernetes cluster when we install Crossplane, and we use Helm for installation here. So, and in this local folder, we have some helper scripts for allowing you to be able to do that. So let's go ahead and actually install Crossplane into our, let's see, our Minikube cluster here. So with the Helm install command, see here it's copying the image, which I built previously, and it's going to install, and it'll show us here in just a moment, all of those different CRDs into the Crossplane system namespace. I think it's dragging a little bit. Here we go. So you can see here, these are all the different CRD types. So just like Crossplane has pods and deployments and things of that nature built in, we've added all of these different types. We were just looking at, for instance, cloud memory store instances in the GCP cache. And there's all these other different kinds you can see as well. What we're also doing is installing the Crossplane API manager itself, as well as the Crossplane extension manager. And I'll get into extensions and stacks, which are other concepts, a bit later on. Once again, here I'll hop over and see if there's been any questions introduced. All right, so Marcus is handling some of the questions here, so I appreciate that, Marcus. But there is this question here, is it possible to use multiple providers of the same type? And Marcus answered that nicely there in the chat. If you can't see the chat, Marcus basically said, yes, you can provide multiple provider objects, and then you can reference those providers differently. So might be useful for me just to jump into actually provisioning one. So let's go ahead and do that. So if we look in the provider directory, I have this little helper script, run.sh, which essentially this private directory is ignored by Git. But essentially what it does is it base64 encodes your Crossplane GCP provider key here, which is in my private directory. So if you create a private directory and name it the same, it'll work fine. And then it also takes a project ID, which is just the way that GCP is set up. And if you want to do this on your own, there's extensive documentation here for how to add your cloud providers. So for instance, GCP, there's a nice walkthrough, and actually if you go to the master version here, I believe there's a helper script in here that allows you to do that, and that's pretty simple to set up. So definitely look into that to be able to do this, but you can use this same pattern here if you'd like. So after it base64 encodes those, it's going to replace them in the provider.yaml that we looked at, and then it's going to create those with kubectl or kubectl. I'm not going to get into that debate here, but we'll do run.sh. And one thing I like to do is put this up at the top here. So let's get all the pods running. So now you'll see that this Crossplane pod and the Crossplane extension manager pod are running. And then what I like to do is get the logs and tail the logs in a separate terminal window here, so I can kind of see what's going on. So to get started, basically the Crossplane controller, which uses the controller runtime Kubernetes project, it basically just added all these controllers and started them. So these controllers are watching for creation of various custom resource definition instances, and then reconciling them, that method that we specified earlier. So let's go ahead and get going here. So, all right, I forgot to have the project ID. Well, we've run into our first mistake here. Apologies. All right, now let's try it. All right, so now we've got our provider set up here, and this allows us to provision resources on GCP and reference this provider, so we don't have to provide credentials every time we do everything. This is just it running in our cluster. So we're going to start off with a bucket here. It's just a very simple one to look at. And you'll notice also that there were no logs here from the Crossplane binary running here in the cluster. And that's because this provider here actually doesn't have a controller in Crossplane, because it's just a configuration, basically saving configuration etcd, which is Kubernetes key value store. So essentially there's no reconciliation that has to happen with the provider. It just has to exist. And the same you'll see with class here. When I create the class that we're going to reference in the claim, there's no reconciliation that happens. It's just saying we want to store this in our key value store for the claim to be able to reference. And when the claim is created, then we'll take the configuration data from the class and do some work in the actual controller. So let's once again look at this class here. And I'll move this for convenience. So this is a generic resource class, which we can just think of all resources classes as generic right now. It has a name and a namespace, as is customary in Kubernetes. And we have these specific parameters that are required for a GCP bucket. So, and we'll look into the actual code that takes these parameters and applies them to the claim in just a minute. But then we also specify that this is a bucket on GCP, which we have to do because this is a generic resource class, so it has no way of knowing that it's GCP. And also this provider reference, this is really important. So that provider we just created, which is named example, and we put it in the Crossplane system namespace, which we often do in Crossplane, is we just put things into this Crossplane system namespace that are more administrator kind of resources. So that would be like providers, classes, etc. And so it's going to reference that, which allows the claim to be able to create a resource because it has those provider credentials that we specified. So let's go ahead and we can create the class. And once again, let me pull up these logs that we're tailing here. This should not cause any messages in the logs, because this is just putting configuration data in the key value store. So we created that resource class. Now let's look at the claim we're going to create. Once again, I need to move this. So this claim it actually provides no configuration data. It's a generic type. So instead of being a GCP bucket, it is just a bucket in the core Crossplane storage API. So this is where we get into that separation of concern. There's no specification that this is a GCP bucket, except for that it's referencing a class that's called GCS bucket, which obviously helps us recognize that it's on GCP. But besides that, it doesn't say anything about, use a GCP bucket. So this could very well reference a class that was an AWS S3 bucket. And that way you can have classes defined. So let's say we also had an AWS provider and created an AWS S3 bucket class. A app developer, someone like that, could just reference that AWS bucket class here and provision it there, or as you'll see later, they can default to whatever cloud provider or resource class is defined as the default. And I'm going to look over at questions real quick because that's kind of an important component. Great question here. So are all classes of kind resource class? So all resource classes right now, except for cloud memory store, and claims are using specific types. Okay, so that's a great clarification question. Thank you for offering that up. And that's in the chat for anyone who hasn't seen it. So claims are what we call abstract types. So let me pull up the repo here. So once again, like I said, we have this core Crossplane API. So in here, we'll do bucket since that's what we're talking about. In storage, we have these types. So we have a bucket type for a claim. So a claim is abstract. So when I say abstract, what I mean is that a claim type is something that could be provisioned across cloud providers. So you can create a bucket on GCP, on AWS, on Azure, on lots of kind of static blob storage providers. So that is an abstract kind, which allows a app developer or someone who's not a administrator in an organization to create a bucket and not care about the underlying cloud provider unless if they want to reference a class specifically. the each of the different cloud providers in turn offer their own version of a bucket. So you'll see here in bucket types under the AWS APIs, we have this S3 bucket. So that's the status. So the S3 bucket here, which is a spec and a status for S3 buckets, and it is a separate type there. So you would create a resource class that specified the provisioner as S3 bucket.storage.aws.crossplane.io. And then when that was created, when a claim was created that referenced that class, it would then create an object of type S3 bucket. So if we look kind of back at the at that architecture document I had up a moment ago. So the resource claim here, these are abstract types, right? So they're general, the bucket, like I was talking about. The class is a generic class, but it specifies a provisioner. So GCP bucket, or bucket.storage.gcp, s3.storage.aws, something like that. And then the resource is that actual S3 bucket we were just looking at in the source code there. So this S3 bucket here, this is what's created. So a user, usually if you're provisioning dynamically, is not going to create this S3 bucket directly. It's going to create, or they are going to create a class that specifies the S3 bucket provisioner and a claim that references that class. And then Crossplane will create this resource and in turn create the S3 bucket itself as an external resource. So I hope that provides a little bit of clarity around that. It can be sort of a complex thing to grasp at first, but it provides a really powerful separation of concern, which we think is super useful in Kubernetes or in Crossplane. So I can dive more into that if that wasn't clear. So please feel free to offer more in the chat if that comes up. So kind of diving back into the provisioning there. What we're going to see, and I should probably go ahead and show that in GCP here, I don't have any buckets in this Crossplane Playground project here. So let's refresh it and make sure that no buckets have been created. Yep, so we don't have any buckets specified here. So what we're going to want to do is create a bucket. And once again, this bucket is going to be created from this claim that we just talked about that specifies the class. So it should have the same provisioning details as the class does. So when we create this claim, we should see some logs up here when it actually gets created here. So let's try it out. Yep, so we see some reconciliation. So first what it's saying is it's seeing a resource claim was created, and then it's assigning that class to the claim, and it's bringing those two things together with the GCP bucket controller to be able to create a GCP bucket. So that would be the resource claim and the resource class coming together to create a resource, or what we call a managed resource a lot of times. So if we look back into Google here, we'll refresh this page. And we'll see that a bucket was created here. And we just specified example bucket and then allowed Crossplane to generate the string. So if we see here, it's a multiple region bucket, which we specified in the class. So if we go back and look at the class here, we'll see that the only parameters we provided here, it's a pretty simple provisioning process, is that it's in the US and the storage class is multi-regional. And you'll see that here, location US, storage class multi-regional. So it used those parameters to create that. And this is great and everything, but there's already a lot of tools that allow you to do this. They may not provide this separation of concern that allows classes to exist and claims to exist, but there is already a lot of resources that allow you to do that. So really one of the really powerful things is using this reconciliation pattern that Kubernetes introduces in its controllers. So in our custom controllers, we watch these resources that we provision and make sure they stay in sync. So if the location changed to something other than US, it would change it back, unless if you also updated the resource in Crossplane. And that provides a powerful guard against drift and that sort of thing. So to show this, what I'm going to do here is I'll delete this bucket, and let me see here. I'd like to show the logs here, because what it's doing is it's checking every so often to make sure that that bucket is still in the state that we wish for it to be in. So if we delete this bucket, so it's gone now. And what we see here is that Crossplane noticed this, and it's going to reconcile that and bring that bucket back to the state, which, and here the change in state was that it no longer existed. And so it's going to bring it back to the state that we'd like it in. So it created the bucket again, once again with the same parameters. So that's a pretty drastic drift there, that it was actually deleted. But it can also, reconcile things like the default storage class or the location, etc. Anything that's used to provision a resource. So let me hop over here and see if there's any other comments. Doesn't look like there's any new ones. So we'll stay on course here. And then when we want to get rid of this bucket, once again, you should not have to use the console at all. You should just be able to interact through this one consistent API across cloud providers. So what we'll do is if we create that claim, if we delete that claim, then we're able to delete that corresponding resource as the controller watches for the deletion of the claim and then cleans up that resource and invokes the delete on the external resource as well. So if we delete this, you'll see that the controller is watching for that and is going to update that appropriately. So now, if we look over here and refresh it, we see that there's no buckets. We just deleted it. So that's a pretty cool example of a simple provisioning process, how it keeps it in sync, and how you can create and delete from this common API, and how you could, create many different classes. So let's say we had a separate class, and instead of something like, we could have a GCS bucket that, was in location Europe. I'm not exactly sure what it's specified on GCP, but let's say EU or something like that. And it could be GCS bucket -EU, and then we also had GCS bucket .US, and you could specify either one of those from any claim that you created and create many instances of US GCS buckets or EU GCS buckets, or as you'll see momentarily, you can default to whichever one the administrator has defined. So right now we still have that class existing, which we're not going to use again, so I'm going to go ahead and clean that up. So we've got that deleted. So let's see here. Now we're going to do a little bit more of a, I guess, interesting or complicated provisioning process here. So we're going to do cache here, which once again can use that same provider that we specified for GCP. So what you'll see here is I have two different types of claims defined. Once again, all of these are in the TBS repo in the Crossplane org. And this is something that is brand new functionality. So you're getting a bit of a sneak peek here, and this will be available in version 0.3, which will be coming out towards the end of August. But essentially, previously in Crossplane, you'll see here, if you look in the repo, we have this default class and deprecated default class. So previously, default classes were implemented using this deprecated default class pattern. And if you go and look in design here, this is a really useful directory for kind of seeing the patterns that we're following, things we're proposing. This is kind of works in progress, where the documentation on the website is, this is how it works currently. So let's look at default resource class. So previously, we specified default resource classes, in ways like this, where you say, this class, you put some sort of label on it, and you say that this is default for this sort of kind. Instead, what we're doing now is we're moving to policies. So you'll see this in the strongly typed class. So like I said, right now we're using this resource class kind in the core Crossplane repo, or the core Crossplane API, excuse me, and we provide this parameters. So for any time, so if this was a MySQL class or a bucket class or anything like that, we just provide the parameters that are specific for that. Well, that's not great practice, because you don't know if you have the correct parameters or if you have all the necessary parameters until you actually provision a resource using a claim that references this class. So what we're doing is we're moving toward strongly typed resource classes. So what you'll see here is with this generic one, you have to parse all of these properties, right, and see if these fields are added in it. And you have to kind of create this spec from the class that's generic. So if we move to a more specific class, more specific resource class, an RDS instance class, for instance, then that is, and this should actually be, yeah, okay, AWS, that's great. So this actually has a spec template, which has these strongly typed fields here. So these are required for provisioning this, and you'll be notified more on creation of the resource class, as opposed to just getting errors and parsing when you create a claim that references it. What this also does is it allows us to create these policies. So we have this strongly typed RDS instance class. So that's, a specific to a cloud provider, AWS. But for MySQL instances, which may, this is generic, right? Or this is abstract across cloud providers in the core Crossplane API. It allows you to specify a specific type of MySQL instance. So we're using this RDS instance class that we talk about here, and we can reference that directly. And that way, if we create an instance, an abstract claim type instance that does not have a class reference. So if we look back up here at a regular claim, it'll have this class reference to one we provided. Well, we can also say you just don't even have to provide a class reference, and it'll just default using the policy for MySQL instances for this abstract type. It's saying for if we want a MySQL instance and we don't care where it lives, it's going to default to this setup of an RDS instance on AWS. So this is a movement that's currently in progress, and so right now it's actually only implemented as a proof of concept for just GCP Cloud Memory Store and Redis. So we can create Redis policies that default to Cloud Memory Store for a Redis claim without a class reference. And let me once again look over at the live stream here. Ah, yes, that's a great point, Marcus. Marcus pointed out here that we should look at the kind of change in status of the resource claim as provisioning happens. So, and this will be a great opportunity to do that, because a cache takes a little longer to provision, a cloud memory store cache, than the bucket does. So it'd be kind of hard to get that with the bucket, but with the cache we can certainly do that. So thanks for bringing that up, Marcus. That's a really insightful point. So what I'm first going to do is, whether we're explicitly referencing the class, which we're doing here, we're doing this class ref, and now we have this kind and API version here because we're referencing a specific kind of class, not just a generic resource class. Or we can say, we don't care what resource class, just use whatever the policy defines, and the policy is defining this standard cloud mem of cloud memory store instance class kind, which we have here in the class. Standard cloud mem, which was in the Crossplane system. So once again, let's hop up in GCP here. And let's look at memory store. See if we have any instances here. We do not. All right, well, this will be easy to tell when the new one's created. So what I'll do first is kind of go in that same pattern as we did with the bucket where we explicitly reference the class, but now it's a more explicit reference because it's a strongly typed resource class, so we have to provide this kind and API version. And then I'll do it by defaulting to that class. And so we'll see what that looks like. So first thing to do is to create the class itself. Let me pull up these logs here. So we'll see the last thing it did was a little bit ago now, was clean up that bucket for us that we wanted deleted. And so we create that class. And now what we're going to do is we're going to create the claim explicit. So we're going to reference that class directly. Alright, so we'll see that it sees that that was referenced, and it's going to set that as the class reference, or excuse me, it already has a class reference since it's explicit. So let's make sure that that's creating now. So let me refresh that. Alright, so it did. You can see it here. It has this location, type basic, version 3.2, port number, instance capacity. And if we look back over at this class that's referenced, we'll see all of these parameters defined here, right? The region, US Central 1, tier basic, memory size GB 1, and it's using that provider. So that's all great, and I'm glad we can do that. That strongly typed resource class is nice because if we had created that in the beginning without the right parameters, since they're strongly typed, it would have let us know that. It wouldn't have let us create it. So there's some of those that are required on that type. So we see here this takes a little while to create. So I'm actually going to go ahead and tell Crossplane to delete it. Which can also take some time just because of GCP, and they'll probably have to finish creating before they actually delete it. So apologies for not having the logs up there, but maybe they're still going. Oh, and I forgot to investigate that again, Marcus. Sorry about that. But what you can do here is with anything you create, so we'll do the class here, which isn't super helpful, but basically we can see that this class exists in the Crossplane system, and since we just deleted that claim, we won't be able to look at it, but normally we can actually look at events here that are happening, and Crossplane will update us as the resource moves through its different stages. So I'll make sure to do that with the claim default, and if I do not, Marcus, please make sure to call me out on that. Alright, so let's see. It might have registered already. We'll see here. It might still be in the creating phase. But essentially, once it's done with that, it's going to go ahead and delete itself. So once again, this ability that we're about to show is only available for Cloud Memory Store right now, but it will soon be available for all kinds, all managed kinds. So what we want to do is with the claim default, we don't reference any class. So how's it going to get its configuration details? Well, it's going to say, okay, and we're using predicates to do this. It's going to say there is no class reference on this claim, so I'm going to see if a policy for this abstract kind, which is a Redis cluster, which is part of the core Crossplane API, it's going to look for a Redis cluster policy. So it's basically a policy saying, if I have a Redis cluster abstract kind claim created that doesn't have a class reference, then I want it to use this class reference. And it'll add that class reference to the claim and then create the resource accordingly. So let's check up on that instance again. So it says it's been created, so it's probably going to be deleting here now in just a moment. Yep, so it's not going to let us delete it because it's already deleting. So that's good. So it's going to take care of that for us. And so what we need to do here is create the policy. So that now exists as well. And once again, what I'll do here is I'll show kind of how this claim progresses through and see the events on it, and then actually on the manage resource specifically, which will be helpful. So once again, this claim has no class reference when it's created. So we'll see here, it's actually going to go through a few different controllers. And let me see if I can actually find the controller up here. It's going to be looking for, might be a little hard to look through these logs here, which is definitely something we're interested in making more user friendly. But essentially it's going to use a default class controller, which takes care of defaulting that claim. So let's look specifically at what that claim is doing right now. So what we'll see here is it set that class reference here to the standard cloud mem. So it took that from the policy and applied that to the claim. And then it also tells us here that it created this resource for us, this cloud memory store instance. So that's what we talked about with the claim and class coming together to create a Kubernetes resource, which represents the external resource. And it'll also tell us here that the condition is that it's waiting for managed claim. The managed claim is waiting for the managed resource to become bindable. So what that means is the managed resource is doing some sort of configuration. And we should look at this instance here, which exists in Crossplane system, and we can get more information about the status of that managed resource. So we'll look in Crossplane system here, and we want to describe a cloud memory store instance kind that is named this long mess of things. And what we'll see here is Crossplane tells us for this managed resource, it also references the claim and class and has all of these provisioning details now that were specified by the class. It tells us managed resource is being created. So that's really helpful. We don't actually ever have to look over in GCP, because we will see here one of those is deleting. So the earlier one, which I believe they have the same parameters, so we'll have to check and see. So that's the top one. So that's the one that's already existing. So this is the new one we just prevented with default class. So it's still in creating mode. And well, actually, while we're waiting for this one to finish deleting and this one to finish creating, and then we'll be able to see that transition here, still in the creating phase, so that's good. I'll look over, see if there's any comments. Doesn't look like we do. So while that's finishing up, that's most of what I wanted to show today. So I'm going to look into kind of the roadmap forward with Crossplane. So as I mentioned, I'm actually using a repository here, deploying from a repository that's not actually representative of how Crossplane currently looks. So KubeBuilder, which is a great project from Kubernetes, which you can find on GitHub as well, recently kind of revised their structure. And because we're going to have all kinds of managed service providers creating their own controllers and API kinds, we want to be consistent with KubeBuilder, which is a kind of standard way to generate custom controllers and resources. And so they had their kind of API folder move out to the top level. So instead of being in here where we have all of this nested stuff, it actually looks like, as I mentioned earlier, that the different APIs are all at the top level. And another important thing that comes with this change is that we are going to be removing AWS and Azure and GCP from the actual core Crossplane implementation and splitting them out into their own repositories, which is nice because it allows us to be able to install these with what we call stacks, or extensions, as they're sometimes referenced to currently, in Crossplane, it allows us to install these as infrastructure stacks. So you don't really need AWS as part of your Crossplane if you aren't going to be using AWS. So you might just install GCP, which would basically add all of those, all these kinds. So when you just installed Crossplane, it would say, you know, anything that is Crossplane specific. So let's see here. So an example would be resource classes. So that's a core Crossplane type, even though that'll be moving out. But these are CRDs that would be Crossplane specific, and then you would go in and you'd install the GCP provider or the AWS provider, or the AWS stack would be more appropriate way to talk about it, since we do have the concept of providers in Crossplane. And you'd be able to use those resources, and it would have its custom controllers that are part of its installation package. And what handles that is this extension manager, which should soon be renamed to Stack Manager. And that's a whole nother process you can read about, as I said earlier, in the Crossplane repo and some of these design documents. So a great place to see kind of our path forward. So if we looked into stacks. So Jared and Marcus have done some great work on this here. And essentially what it does is defines how stacks will be installed and that sort of thing. From a user perspective, this should all be pretty seamless, but it's useful to read through here and kind of understand how that's going to work. And another important thing to note is there's this concept of infrastructure stacks and application stacks, which are just kind of working terms. But what you can do when you have this claim and class concept here is you can introduce applications. So like a WordPress stack that you could imagine specifies claims. Let's say WordPress needs a bucket, and it doesn't really care if it's on GCP or on AWS or on Azure. It just says, I need a bucket to be able to do what I need to do. So it would specify that it needs a bucket, and you could have, let's say you had GCP and AWS providers installed, and you had bucket classes for each of them, an S3 bucket class and a GCP bucket class. And then you had a default policy that allowed you to specify which one you wanted to fall back on. The WordPress stack itself isn't concerned with which kind you use. It just says, I want a bucket, and we can provide this portability across cloud providers because it uses this abstract kind concept, which is a really valuable separation of concern and introduction of portability. So we're excited to be moving towards that. Another thing I mentioned earlier was the implementation of strongly typed resource classes, which we explored a lot through our through provisioning that GCP Cloud Memory Store instance. We used a strongly typed resource class that was defaulted to, and those policies become available when we use strongly typed resource classes as well, which is useful. So all of these things kind of work in tandem. If you ever want to see kind of what is our current focus, it's useful to look at these epic labeled issues here. So you'll see we have a number of epics defined right now. They're broadly grouped into services and stacks. So you'll see here's one that's assigned to me. So this is related to implementing strongly typed resource classes. So what you'll see here is there's some issues that represent the actual broken down work here. So implement strongly typed resource classes for GCP Cloud Memory Store. This has actually been closed because that has been implemented. And then for something like creating strongly typed resource classes across the entire repo, that has not yet been implemented yet. So these epics are really valuable. Another thing for an even more broad overview is to look at our roadmap document here, which we have some great people working on. And you'll see kind of our broad priorities. So this actually references those epics, so it may be even more useful to look here. You can also look more into the future about what we're interested in all the way to v1.0. And I will make sure there's nothing popping up in the chat. Let's see. All right, Jared, thanks for joining. All right, it looks like, yeah, extensions and stacks, that'd be really useful. And we have some great people who are actually going to be a lot more equipped to do that than me in a future episode. So I'm excited to get all kinds of people on this this stream. And like I said, if you join the community and think you have valuable thing to offer in a show, then we'd love to have that as well. Anyone is always welcome. So kind of to conclude here, let's jump over and look where we're at here. So it looks like we finished provisioning that cloud memory store instance there, which this is the one defaulting. You also see the other one was deleted. So it has this instance capacity that we specified, everything that's specified in that default resource class that it referenced via the policy, that defaulted to via the policy. All right, so that gives you kind of a broad overview of what Crossplane is about. It's been really awesome to do this show. And like I said, all of these resources are here in the TBS repo. And I'll also be updating this README with some notes from the live stream. And then another important thing is if you want to go here, and if you want to open a new issue, you can suggest a topic for us to cover in a future one. So it sounds like Jared might have a topic that he'd like to suggest, so he could open an issue if he'd like. And yeah, and we'll go from there, and we'll try to help with the community as much as possible. Any areas you want us to dive deeper into. And also one thing I just want to note is, like I said, I have my my handle here at the bottom, #Dan. Please feel free to reach out to me directly, and I don't want to speak for everyone else who's a member of the Crossplane community, but in general it is very open, and people are willing for you to reach out to them directly. And I know I definitely am. I'm on Twitter and GitHub, and I'm also in the Crossplane Slack, which is a great place to learn more about what we do here. So with that, I'll go ahead and wrap up this show. Please feel free to provide any feedback, anything from presentation style. It was probably a bit jumbled this time, so we'll try to improve upon that. But any feedback you have, any future topics you'd like, please feel free to offer them. Thanks, everyone. Have a good week.